All right. Hey, everyone. Good morning. Yeah, thank you. Clicker's always nice. Welcome. And we've got a lot of things to cover this morning. I guess I just wanted to start off sort of saying thank you, because all of you have been involved in making Java what it is today. These numbers are from an independent study, and I think we know that the programming language landscape is one that is very trendy. There are always new things that are coming along, but I think one of the things that people tend to sort of forget is the solid technologies that are running the world and keeping our enterprises going, and Java remains extremely popular there. And I think we're going to hear more about that in a little bit here. As you know, and you've heard me say in previous years, we've been focused on making the machine of delivering Java to you one that is very dependable, predictable, with regular new releases, bringing you new features. And as you can see, this is sort of where we are now. Java 25 released just a couple of weeks ago. And in this, we said the next LTS, and I put it in double quotes. And there's a reason that I do that, which is if you speak with any people on my team or the extended set of folks across the industry who are contributing to these releases in OpenJDK, they will point out that LTS is not an OpenJDK thing. It is a vendor-specific thing that many vendors offer, giving you support. From our perspective, doing the new releases of Java, every release is production ready. Now, what that means to you as a developer could be different, right? Basically, the sort of advice and the way many enterprises think about this is they want something stable that they can use in production, that they're going to run for a long period of time, and be able to just take new versions that fix security issues, but not necessarily have a bunch of new features and disruptiveness. As developers, though, working on the next thing, we want access to new features as soon as we can get them. And so one great way that I see a lot of enterprises thinking about this is we have a version that we use in production that's kind of at a stable baseline. New development that we're doing, we're constantly taking in new things and using the fact that we can have CI/CD pipelines to always be testing future things, understanding how it's affecting us. And so basically, as a developer, we are always getting the new things. The things we're running in production, we can plan when we're going to move forward. So I think this is sort of a good perspective to keep in mind, because from our perspective, all of these releases are production releases. Okay, and so when we do this development, I like thanking all of the people who have helped bring this to you. This is sort of a heat map showing you that Java, unlike many technologies out there, is one that is coming from a bunch of different sources. So basically, the large bulk of it come from my team at Oracle, but there are people all the way across the industry, different companies, bringing different backgrounds and experience. And in fact, the second largest group is independent developers, right? So people who aren't even necessarily affiliated with a company, but that are coming and contributing their expertise. So this is just 25. Now I'm going to bring Nicolai up to talk more about 25 and show some practical examples.
Thank you, George. Morning, DevOps. So who here considers themselves a developer and likes telling the machine what to do? Now keep your hands up. Who is amazed by doing that? Whose family thinks the same? Yeah, that's what I thought. So just to continue that topic. So it's the same for me. My family is not impressed by me telling a machine what to do. They're more impressed by me being able to do some video editing, for example. And so I occasionally help them with that. So my wife, she's working for NPH, which is an NGO that supports vulnerable children in Latin America. And she asked me to help her with the video project. She had a video file, and she had a subtitle file, and she asked me to burn the subtitles into the file. A subtitle file looks like this. A simple text-based file. It has every subtitle has an ID and a time span where it is shown, and then the actual text that you want to see on screen. So okay, you take the file, you take the subtitle file, or the video file and the subtitle file, you bump this together, and you get something like this. Ignore the German. I hope you can see the issue here, which is this line break. Like, what's going on here? That looks odd. So in the first couple of minutes of the video, I saw like 3 of those occasions. That looks broken, so let me look at the subtitle file. And it turns out it sometimes had an actual hard line break in the file. Well, that sucks. I need to fix those. I need to find those first, though. I'm not going to scroll through the entire file. It's like 300 of those subtitle entries. I don't have the time for that. So instead, I thought I'll program a little code, write a little script. And because I only know Java, I wrote the script in Java. So I want to lead you through a couple of these features that have been introduced in the last couple releases that if you're coming from JDK 21, you might see at least some of them for the first time. And a lot of them are under this rubric of paving the on-ramp, which should make programming easier for beginners, which is definitely what they're doing. But also, they can help us more experienced folks writing scripts like this in Java. So I want to quickly go through this. First of all, this is the main.java file. There is no class, there's no static, there's no public, there's no string array. It's just code that does a little thing. So first of all, it opens up the subtitles file, and then it does a gather, mygatherer.slicing. What's up with that? What's it doing here? So let's talk about gatherers. They were introduced in JDK 24. A gatherer works like a collector, but in the middle of a pipeline, meaning it generalizes the idea of what is a step in the middle of the pipeline. And it consists of 4 building blocks. I'm going to talk about the 3 most important ones here. The first one is initializer, which will create a new state. I'm using an array list as a state. Okay. And then there's 2 more building blocks, the integrator and the finisher. The integrator takes the state, takes the current element, and the downstream, meaning the next stream operation, and its task is to do something with the state and the element and eventually push something downstream. We're going to see what it's doing there in a second. And the finisher runs at the very end when all the elements in that stream have been processed to be able to do something at the very end of the pipeline, of that step. And notice that there's a predicate being passed in here that didn't quite make the line. It's called slicer. So let's look at that. Okay, so what does the integrator do? It wants to slice the stream. It wants to, on specific lines, wants to pull the stream apart into sublists. So that means this integrator has, as an input type, the element type, and as an output type, the list of elements that it's going to create, and it has a list of elements as a state. So it takes this predicate that came in, the slicer, and sees whether the element passes it. And let's jump to the it doesn't pass it. If it doesn't pass it, it just dumps the element into the list. Right? So it starts building this list with all the elements that do not fulfill the predicate. If they do fulfill the predicate, it creates a copy of the list, pushes it downstream, and then clears the state so it can start over. So you can see this thing as it goes through all the elements. Everything that passes the predicate will lead to a slicing of the stream into a sublist. And then the finisher does something very simple. Just take a copy of the state and push it downstream as well. Okay, and you can put all of this together, and now we can go back to the stream pipeline. Now we can better understand what it's doing. So remember, the subtitle file looks like this, and these blocks are separated by empty lines. So what's happening here is it takes this stream of the lines from the file and just slices them on every empty line, right? So I get these blocks that are left over. So now I have a stream of list of strings. And now I feed them into subtitles.new, or ::new. What subtitles? Well, it's a record. You've probably all seen record, so I'm not going to spend a lot of time here. The thing is, this also makes something like scripting super easy because very, very often you can have a proper, strongly typed representation of what you're working with. You don't need to just use strings and have it often just be a one-liner. Here it's a bit longer because I want to have this constructor that takes in this list, right? This block that I have that looks like this and then just maps it to a new record instance. And also, I will later figure out, I'm going to show you in a second why, what is the maximum line length there? And for that, simple stream pipeline, you can see all this is very straightforward. And so I end up back here, and now we can start to understand the rest of this pipeline, which is I'm streaming over the lines in the file. I'm turning this into blocks. I'm turning this into these subtitle instances. And then I'm going to do a little bit of filtering, like I want to kick out the ones that only have one line, right? Remember, I'm looking for the broken lines. So I'm filtering all those out. Then I sort them by length. And I just want to see the first 5, because I thought there's probably many of those. I just want to see a few of them to get an understanding of what the actual issue is before I go back to the video editor and decide how do I want to fix this. Okay, so I've done all this. How do I run it? It's very straightforward. Even this line break was not my original presentation. So imagine this is a folder, and then the folder has like 3 files in it: main.java, mygatherers.java, and subtitle.java. I could have just put it into one file. But even as it grows a little bit, the project, you can start splitting into several files, but you can keep using the simple Java launcher command to launch it. So this is all that I need to launch it. I just point the Java launcher at the source file, and it will figure out that, well, it's a source file. I need to compile it in memory. Oh, it references this mygatherers.java. So is there a file like that? Oh, yeah, it is. So I can just load that file, compile that file as well. And it all works well and worked really great. And the end of that story was the 3 occurrences that I saw in the first couple of minutes. That's all of them. So the half hour I spent on this was totally for naught. But it gave me a great example to show you here, which I thought was worth it. Okay, but Java 25 has so many more things. And again, for those of you coming from 21, there's even way more. So clearly, we cannot possibly talk about all this here. I talked about a bunch of that for 3 hours on Monday morning, but even then I couldn't cover everything. So if you want to learn more about this, the internet is there for you. Java has a great YouTube channel that I contribute to, but also a lot of my colleagues. So you can follow videos about this as well. But there's also talks on many of these things. So if something interests you, figure out which talk at this conference is there that cover this, and then learn more. I want to go over a few things, though, not in much detail, but at least I want to cover a couple of the interesting things. So one thing is that while often not an outright feature, something you get with every new JDK release is just better performance. So this is from a spec JBB benchmark, which I hear it's very hard to get even like single percentage increases. So between Java 21 and Java 25, you can see a 5 to 10% increase here in performance numbers. Now, this is just from running on 25. You don't need to recompile. You don't need to update anything. You can just run on the new Java version. If you come from older Java versions, it looks even more promising. Specifically from 8, the jump is pretty big. Now, none of this is a promise that you will see exactly these numbers in your application. It's just an indication that things are getting faster, and your numbers may vary. They may be higher or lower. For example, we've tested Helidon. That is just the same app. Requests per second on 21 to 25, you even see a 75% increase. So there's good reason to believe that your application will just run faster in your Java versions, and that for many of you also means that it's going to be cheaper to run them. Okay, now I have to warn you. Oh, no, wait. I'll warn you later. We're going to talk a little bit more about performance. If that is not enough for you, you have a new command line option that you can try to make memory usage more efficient. So on your heap, there's your payload, all your strings and characters and integers and lists and whatever, but there's also always the object header. And the object header used to be always 12 bytes. Well, it could actually be larger, but it's 12 bytes was the minimum that you would achieve on a 64-bit system. But the actual payload usually is not that large either. So 15 to 30% of your heap might just be headers, which are important for the JVM to run, but we really don't care about it. So with the new command line flag that Project Lilliput introduced, which is plus use compact object headers, you can activate compact object headers, which will reduce them to 8 bytes. Now, this is a bit of a trade-off. This compression may take more CPU cycles to decompress some of the information. What we definitely see, which is what expected, is less heap space and fewer garbage collections. That makes a lot of sense. Interestingly enough, you might also see overall less CPU usage because the cache locality helps, for example, the less work that the GC has to do might help. So we can see in some benchmarks even overall improvement here. So if this is interesting to you, try this out. And whatever the results are, please report it back to the mailing list. The JDK enhancement proposal linked at the bottom there, 519, has a link to the mailing list. This could in the future become the default. It could become the only way to handle headers. This is based on the experience of the larger community, so please do report that back. If that performance is not enough for you, you can also look into ahead-of-time compilation. That's something that came to fruition over the last couple of years and is going to be pushed further. The idea here is to combine Java's dynamism with better startup and better warm-up in a 3-step process. These 3 steps exist always spiritually, most often also technically, although there can be shortcuts that you might be able to take. But how they work is you observe your application, a training run, you gather information there and put them into a cache, and then that cache can jumpstart the JVM. So the next time it launches, it doesn't have to redo like the profile gathering, for example, of your application or the bytecode loading. You can just take the old data that it gathered during the training run and start working from that one. And here are some numbers that compare the startup time, the time to first request, in several different web frameworks. It doesn't matter whether Helidon is faster than Quarkus or Spring Boot is faster than whatever else. This is about the comparison of the JDK of AOT. So they're all normalized, right? So all normalized to 1,000. And you can see a drop in anywhere between 50 to 80% in launch times if you do this AOT caching. And this is, the middle bar there is 25 with AOT as it exists now. And Leiden recently had a new early access build that contains more improvements. And we can hope that those come to the JDK in the next couple months and years. And so there's more improvements to be had. And surely the guys are working on something after that. OK, this was the slide I want to warn you about because it's bright. I'm sorry for the not dark theme. We only had those images on white. This is about the foreign function memory API, something that was finalized in JDK 22, something that very few of you will probably use in practice yourselves. But it's important because the tools you are using are internally using it. We're seeing great adoption there. But also projects are writing wrappers. So if you want to, for example, use LLM or Vulkan or FFmpeg from Java, then you can do that through a Java wrapper that is written with the foreign function memory API. So this is really going well as well. Two things I want to show you as a preview that are currently a preview in JDK 25 that you can also try out and report feedback on is the structure concurrency API. I will not go over all the details. There are plenty of talks about this. One of them will be from me tomorrow afternoon, and then Krishna will give one on Friday morning as well. The idea behind structure concurrency is that you do not start threads and enqueue more computation and then wait for threads to finish all over your code base. So you start concurrency in a block, and then you end it in the same block. And this is the API that allows that. It works with virtual threads because that allows you to start threads everywhere without worrying that too many threads would harm memory usage. The other thing I want to briefly point out is the PEM API. PEM is Privacy Enhanced Mail, which is an acronym. But you see these blocks, you've probably seen that on GitHub or somewhere else where you upload a certificate. Java now has an API that makes it very easy to just turn that string into a Java cryptographic object that you can then handle from then on. And yeah, again, it's a preview API, so please try it out. As I said, there's so much more in JDK 25. I hope you get to see more about all that during the rest of the week. Now, all of these projects, all of these ideas don't come out of nowhere. They do come out of, or many of them do come out of these projects. I want to give it over to George to talk a little bit about that.
Okay, thank you.
Thanks.
Okay, so you've probably seen this list before. This is one that we have shared for a number of years now. And this is talking a little bit about the kinds of things that we think about when we think about what projects to start and where we want to innovate. And I think the main takeaway from this should be we have a number of projects that are going. Many of them are interrelated, but all of them are about trying to understand fundamental problems or challenges, things that are hard to do with the Java platform as it is today, and think about how we can alleviate those problems so that you can find solutions in the future. So this is a fairly dry way of looking at it. So we also think about it in other ways, right? Our main goal here is not to take some solution that someone has come up with and then try to find the problems you could solve with it. Rather to sort of understand what are the sort of general problems that are coming up, and what does that suggest to us about things that people want to do with Java that they're having a hard time to do, and how can we sort of remove those things out of the way and get innovation to you. So we see this, another way of looking at these projects rather than a dry list is sort of what are the areas that they help you with. And these are a few of these things, right? We know that security, of course, is always important and sort of permeates everything that we're doing going forward. But we're looking at, as we're moving to a world where data is more and more important, how can we help you focus on the kinds of problems that that brings about? In addition, a lot of the deployment we see now is cloud. It's been moving to cloud for many years. In fact, Java is #1 in the cloud. And what are the kinds of challenges that that brings that we can help with? And of course, most recently, as we've gone from big data to ML to AI, what are the kinds of challenges there? And so, as we're looking at that, right, we're thinking, diving in on the AI side of many different areas. People talk about AI, but AI is many things, right? There's Gen AI, and what can we do to make sure that Java is a great target for, for generating code, but also, what about taking a model and integrating it with your existing business apps? Right? That is going to increasingly be something that people want to do, not just playing with these things over on the side, but actually really integrating it to your existing applications. And then one step further, rather than just wrapping these models somehow, how can we actually make it so that the models are done natively in Java, where it feels like a natural first-class citizen? And so in order to talk about that particular area and a project that we initiated a little while ago to start to look at that, I'm going to ask Paul Sandoz to come up and talk to us a little bit about Project Babylon.